day everyone, I am Arman Joseph F. Watka from BSc TLD, and today I will explain the conservation of mechanical energy using this example. So let's go! Sample number 1. A man of mass dropped from a board 10.0 meter above the water surface neglect Earth's resistance. A. Use conservation of mechanical energy to find his speed 5 meters above the water surface. B. Find his speed as he hits the water. As we can see the figure, consists only the diver and yung kanyang reference na ground, and as a diver falls, only the force of gravity acts on him. Again, nine-neglect natin yung resistance, so the mechanical energy of the system is conserved. And gagamitin yung conservation of energy for both parts. So from this point, start siya dito. For example, ito yung ating reference line. And ang velocity niya dito, since dito siya nag-start, is 0. Therefore, our kinetic energy natin dito at the initial is 0, and we have the potential energy here. Potential energy here is equal to mass times gravity at yung y position. Dito siya nanggaling now from this point and this point. Meron tayong kinetic energy dyan, of course. So let's start from the letter A. Solve muna natin yung speed 5 meter above the water surface at this point. Kasi sinahanap nga natin yung velocity, ibig sabihin meron tayong kinetic energy dito which is unknown. So this is the final. And meron din tayong potential energy dito dahil meron tayong position na 5 meter above the ground, above the reference line. We have potential energy final. Nalagay natin na hindi din natin alam, and by conservation of mechanical energy, letter A, initial is letter G, energy initial is equal to energy final. So kinetic energy initial plus potential energy initial equals sa kinetic energy final plus potential energy final. And by substituting the equation, we have here 1/2 mass times the initial velocity square plus mass times gravity na sa final position is equal to 1/2 mass times final velocity square plus mass times gravity final position. Pwede na natin i-cancel yung mass, and 0 na rin yung ating initial velocity dahil nag-start siya from rest. 0 na to. So natira ang equation natin, we have gravity position equal to 1/2 times final velocity square plus gravity final position. We derive the equation to solve for the final velocity. So we have here G times y initial equals sa 1/2 B final velocity square, and multiply natin both sides sa 2. Para makancel yung 2 dito. And factor out natin tong G. So we have now 2 times the gravity y initial minus y final equal sa final velocity square. So, square root ng both side para ma-cancel yung square. So, final velocity is equal to 2 times G times Y initial minus Y final. Substitute na natin yung given values, final velocity at 5 meters to above the ground and 5 meter. So this is at 5, the square root of 2 times 9.81 meter per second squared times 10 meters minus 5 meters yung initial and final position natin. So by calculating, final velocity is equal to 9.9 meter per second. Ito yung velocity niya at this point. For letter B naman, the speed niya as he hits the water, ito sa point na to. So in potential energy natin dito is already 0. Just sa makakancel na natin yun. So we have 1/2 mass times initial velocity square plus mass times gravity final position initial position equals 1/2 mass times final velocity square plus mass times gravity final velocity square. Again, yung final position natin is already 0. 0 na agad. And 0 na rin natin yung ating initial velocity. Pwede na natin i-cancel yung mass. And ang matira na lang sa atin sa equation is G times initial velocity times y initial velocity, G times y initial equals 1/2 times final velocity square. And yung final velocity natin is at the reference. Ayan, reference siya. Ito na tayo doon sa water. Solving for the final velocity, we cross multiply. So this is 2 times G Y initial equals sa final velocity square. And square root ng kabilang side para maka-answer ito. So, final velocity natin is equal to 2 times 9.81 meter per second square. At yung initial position natin na 10 meters. So, by calculating, ang final velocity natin is 14 meter per second. So, This is example for the conservation of mechanical energy.